When you attempt to master a complex new field, your natural instinct is often to memorize individual facts, data points, or terms. Today, generative artificial intelligence software can retrieve and summarize those individual facts for you in seconds. However, knowing isolated pieces of information does not mean you understand how an entire system functions. If you focus exclusively on individual data points, you will fail to predict how those parts interact over time. True comprehension requires a shift from isolating individual pieces of information to analyzing how those pieces interact within a larger network. In the mid-20th century, biologist Ludwig von Bertalanffy formulated general systems theory. He established that a system, whether it is an economic market, a biological organism, or a corporate organization, cannot be understood by looking at its components in isolation. Instead, you must analyze the relationships, flows, and structural interactions between those components. When you change one part of a system, it alters the performance of other parts across the entire network. Systems thinking is the conscious practice of mapping these relationships to understand the behavior of the whole. Environmental scientist Donella Meadows expanded this field by researching feedback loops and leverage points. A feedback loop occurs when the output of an action modifies the next input into that same action. Balancing feedback loops keep a system stable, while reinforcing feedback loops cause exponential growth or decline. Meadows demonstrated that inside any complex structure, there are specific areas called leverage points. A leverage point is a place within a system where a small structural shift can produce a major, permanent change across the entire network. Identifying these points allows you to solve chronic problems instead of just managing immediate symptoms. This is where human intelligence maintains a distinct advantage over automated software. Generative artificial intelligence models excel at processing massive quantities of localized data points and identifying statistical correlations within specified text or code bases. However, algorithms operate within the specific constraints of their training data. They do not naturally evaluate systemic feedback loops or anticipate unintended, cross-disciplinary consequences that occur outside their immediate parameters. While an AI can optimize a single step in a process, a human systems thinker can analyze how that optimization alters the entire organizational network. To master complex topics in the modern world, you must stop trying to compete with software on raw data memorization. Instead, practice identifying structural patterns. When you study a new business, a scientific topic, or a social issue, ask 3 specific questions. What are the primary components? How do they communicate with each other? And where are the delays in that communication? If you find this systematic approach to learning valuable, please click the like button and subscribe to the channel. Let us know in the comment section below which complex system you are currently trying to understand in your own career or studies. Complexity is not something to avoid or fear. It is the exact environment where your unique capacity for strategic, macro-level systems thinking becomes your primary cognitive strength. Map the network, locate the leverage points, and direct the process.